Question number 31, everyone. A small circular loop of radius r is placed coplanar with a square loop of side small l, such that L is much greater than R. If center of both loops coincide, then the mutual inductance of the system will be what? So, according to question, let us consider a square loop, kind of something, and we are having a circular loop, a very small circular loop at the center, coinciding. Now we have to calculate the mutual inductance. Suppose I current is flowing in here. So, magnetic field at any point at the center can be given as B net equals, this is wire 1, this is wire 2, wire 3, wire 4. 4 wires we are having carrying same current, locating at the same distance from the center, making this same angle 45. So 4 into B, that is 4 into magnetic field due to one wire, mu naught I upon 4 pi. Separation, this will be L by 2. So L by 2 within bracket sin theta 1 plus sin theta 2. Sin 45 plus sin 45, 2 sin 45 degree. Solving it, B net, we will get mu naught I 2 root 2 upon pi times L. Now, we know very well that flux is given by M into I. Flux phi equals to magnetic field into area. Magnetic field mu naught I 2 root 2 pi L. Area of this circular loop, that is pi small r square, equals M into I. I gets cancel out, pi cancel out. The mutual inductance we have got mu naught 2 root 2 r square divided by L. Now let's try to find out the options. We have option number 1 perfectly matching with our answer. So we'll go with option number 1 only. Now move on to the next, that is 32 number. So here is question number 32, everyone. The current that flows through 4 ohm resistance nearest to the battery in an infinite ladder of network of resistances constructed with 2 and 4 ohm resistances are shown in figure will be. See, since this is an example of ladder containing infinite resistances, so we can separate this part out, and this will be equivalent resistance R. Circuit can be modified as 2, 4 R. Now the total resistance is given by, this total resistance will also be equal to R. So net resistance R will be equivalent of these three, that is 2 plus 4R upon 4 plus R. Solving it, we will get a quadratic equation, that is R square minus 2R minus 8 equals 0. Two values of R is possible, 4 ohm and minus 2 ohm. Resistance cannot be negative. 4 ohm will be our answer. Now this is also become 4 ohm. Total current drawn from the battery we can calculate now. The total current I total will be what? 8 upon 4, that is 2 ampere. Now 2 ampere is the total current drawn from the battery. Here the current will divide into two parts depending on the resistances. Since they are equal, so current will be equal. I equals 1 ampere. So we'll go with option number 4, which is absolutely correct. Now move on to the next, that is 33 number. So here is question number 33, everyone. The logic gate as shown in figure performs the logic function of NAND, NOR and OR. Okay, AB, here you will get A dot B complement as output because this is NAND gate. Now inputs are same, this is R and here is NOT. So combinedly this is NOR gate, the latter part. We can solve it. Y will be what? Suppose this is input X1, this is input X2. So X1 plus X2 whole complement because NOR gate it is. Now X1 is what? A dot B complement plus X2 is what? A dot B complement whole complement. In Boolean expression, A plus A always gets you A only. So this together will give you only A dot B complement, whole complement, and ultimately we are getting A dot B as complement and complement cancels each other. It is performing the function of AND gate, so we will go for option number 3 only. Now move on to the next, that is 34 number. 34 number everyone. A particle is thrown with speed u at an angle of 60 degree with the horizontal. When the particle velocity is directed at an angle 37 degree with horizontal, then the radius of curvature of path at that instant will be. So according to question, we can have a diagram. The particle is projected this way, and at certain instant it is moving along this line. Speed is v, suppose, projected with u. This is 60 degree. Horizontal component we can write u cos 60. Horizontal component right here we can write v cos 37 degree. Now since we know that there is no acceleration in horizontal direction, so horizontal velocity will always be constant. So therefore u cos 60 must be equal to v cos 37 degree. Cos 37 we have to put 4 by 5. Now after solving we have v equals 5 u divided by 8. Now at this instant we are having gravity g vertically downward. Let's break the component. G has one component g cos 37 along this direction and g sin 37 along this direction. Now we know very well, in case of circular motion, the centripetal force AC is given by v square by r, where v is tangential component of velocity. So here tangential velocity is v, so therefore we can write g cos 37 is acting like centripetal acceleration. AC equals g cos 37 equals v square by r, where r is the radius of curvature now. So we have r equals v square upon g cos 37. Putting the values of v, we have v square, that is 25 u square upon 64 multiplied by g multiplied by 37 cos, that is 4 by 5. Solving it, we have radius of curvature as 125 u square upon 256 g. So this is the result we have got. We will go through option number 3. Absolutely correct. Now move on to the next, that is 35 number. Question number 35 everyone. The minimum force required to keep a block of mass 1 kg at rest against a rough wall having coefficient of friction between the wall and block mu 0.5 is capital F. If a force of F by 3 is applied on the block as shown in figure, then the acceleration of block will be what? Now if we are applying a force F, then what will happen? Normal reaction will also F. Since it is at rest, limiting condition, so we have mg acting downward, limiting friction acting upward, Fs. Fs is mu into n equals mg. Mu, n has F value m1 g10. Mu 0.5, we get the value of F, that is 20 Newton. If this force is less than F, then certainly the block will move. Now let us talk about the second condition. If F dash equals F by 3, that is 20 by 3 Newton, normal reaction will also be 20 by 3 Newton. Now in this case what will happen? The block will accelerate. Block will accelerate now. So therefore we have the forces mg minus kinetic friction will act F equals m into a. Mg m1 g10 minus F, that is mu n, equals ma, 1 into a. 10 minus mu 0.5, that is 1 by 2, you can write n equals 20 by 3 equals to a. So therefore, after solving, we will get the value of acceleration, that is 20 by 3 meter per second square. Final answer this is. So we can go through option number 4, which is absolutely correct. Now move on to the next, that is 36 number.